Problem 24. Which representation of molecular art better shows a solution of NaF dissolved in water? Explain your choice. Will this solution conduct an electric current? So you're given two representations of molecular art. They're pretty similar. The one on the left has the little black atoms, and then the little yellow atoms are two atoms put together. And then the one on the right, there's only one yellow atom per particle. Everything else is the same. So the key is in the formula, NaF. This is an ionic compound, and you can recognize it as such because you got the metal sodium and the non-metal fluorine. So metals and non-metals tell you you got an ionic compound, and this is called sodium fluoride. Now, sodium, we know, when it's part of an ionic compound, is in the form of Na plus ions, and for every one of these you're going to have one F minus anion, and that's why the formula is one sodium and one fluorine. So one of these for every one of those. So the compound itself, this is a little bit extra stuff. We probably don't need it to really solve the problem, but we'll mention it anyway. The compound itself, in the solid form, it looks something like this. It's a nice three-dimensional crystal structure, and for every sodium you have a fluoride, and the ions line up. They're alternating one after the other, after the other, after the other. Positive, negative, positive, negative, positive, negative. The ratio is 1 to 1, and it goes in all directions. One of these, and then one of those, one of these, and then one of those. And you can see that every sodium is surrounded by fluorides, and every fluoride is surrounded by sodiums, and nice and beautiful structure. So when you dissolve this structure in water, water is good at ripping apart ionic compounds, and all of these particles become separated from one another. So what it's going to look like in water is the sodium cations are going to become separated from the fluoride anions. So this looks a lot like B. So the sodiums and the fluorides are one ion. There's not two sodium ions connected together. They're all separate. That's what ionic compounds do when they dissolve in water. All of the ions separate from each other, and the fluorides don't match up. You don't have anything like this going on where two negative fluorides pair up. So this is going to be solution B. Now this is an electrolyte, and that's because we're talking about an ionic compound that's dissolved in water. The dissolved ions allow electricity to flow through the solution. Anytime you have an ionic compound dissolved in water, it's an electrolyte. So it's going to be B. Now just a little bit more on solution A, or mixture A. Just a little aside. Let's remember what we talked about back in chapter 2 when we discussed elements. The elements sodium and fluorine, when they're elemental substances, sodium is a metal, and it's made of sodium atoms, and it's usually a solid. So here's what solid sodium metal looks like. Fluorine is a gas, and it happens to be one of those diatomic molecular elements. Two atoms of fluorine like to attach together to form molecules. So several elements do this. Oxygen comes in the form of O2, fluorine does this, and several others. And this is what the elements look like. Now imagine if you were able to dissolve the elemental substances in water. Well, anytime you dissolve something in water, the particles become separated, so all the sodium atoms would float around separate from one another, and all the fluorides would be in there too. Not fluorides, but fluorine molecules would be in there too, and it would probably look something like this, and that looks an awful lot like solution A. So when I'm looking at this, I see, wow, this looks like a fluorine molecule, and these look like sodium atoms. That's not right, because we're talking about sodium fluoride, the ionic compound, and an ionic compound, for every one sodium cation, you have a negative fluoride anion. So it's not like this, it's more like that.